the science behind all this. Joining me now from Thuwal in Saudi Arabia is Martin Mai. He's a professor of geophysics at the King Abdullah University of Science and Technology. Martin, good to speak with you. I think perhaps, at least for me, one of the most shocking events of this natural disaster is the fact that the region experienced two extremely powerful earthquakes in a relatively small, short window of time. I mean, is this normal?
Good afternoon. No, it's not normal. As you alluded in your introduction, there were a sequence of aftershocks, magnitude 6, 6.5, and aftershocks will continue for weeks and months to come. These second shock, nine hours later, in my opinion, cannot be classified as an aftershock in the classical sense. And the reason is that it's about 100 kilometers away, but more importantly, it's on a separate geological structure that runs as a fault line east-west away from the main fault that ruptured, the East Anatolian Fault. And the magnitude is almost as large as the first main shock. So we would classify it as more as a doublet of two powerful earthquakes. They are connected physically, but they're not a main shock aftershock sequence as such.
Okay. Martin, we have been crossing to our reporters throughout the region, and I want to ask you this, if you could sort of provide sort of a scientific explanation. When you look at sort of the provinces of Kahramanmaraş, where the epicenters of these two, in your words, separate powerful earthquakes happened, more than 100 kilometers away in Hatay, it's a province that borders the Mediterranean Sea. It has experienced perhaps the most devastating damage. Why is that due to the soil composition and the way that it absorbs some of the seismic shocks?
Yes, this is very likely. So Hatay, as far as I can see, is located sort of in a relatively flat terrain. So we would call this a sedimentary basin. And the material there is relatively soft. And that material amplifies the ground shaking, or can potentially amplify the ground shaking. And the second part then is, this amplified ground shaking may be associated with some liquefaction, so that water squirts out and makes the ground even softer, and buildings then more easily collapse. And of course, the third factor is that, the construction style, the building quality, the construction quality is essential. And I don't have any information on that, but maybe that, these three factors come together in Hatay.
Martin, I want to sort of ask our director to sort of bring this map up once again. What we're seeing is that obviously Türkiye lies on multiple fault lines. This one happens actually on the Eastern Anatolian fault line. I'm wondering if you could actually maybe provide a little bit more information with regards to the seismic activity that we've seen on the Eastern Anatolian fault line, whether or not it has the potential to trigger more seismic activities on, let's say, the Northern Anatolian fault line. And I ask this because of where we're situated in terms of a highly populated city like Istanbul. Do you think that it could actually have a domino effect in terms of creating more seismic activity on neighboring fault lines?
That is an excellent question, but also a very difficult one to answer in detail. Let me start that the North Anatolian Fault in itself has experienced what you describe as a domino effect of many or several large earthquakes in the early 20th century, right? This was kicked off with the 1939 earthquake way in the east, and then there was a sequence of earthquakes in succession moving sort of to the west until the 1999 earthquake that was near Istanbul in Izmir. The two earthquakes that happened 2 days ago, they are quite far away from the North Anatolian Fault. And an immediate direct effect on the North Anatolian Fault is probably unlikely. I'm not saying it's impossible, because the stress waves that were generated 2 days ago, they propagate around the globe. I mean, seismic instruments measured these earthquakes around the globe. And so there can be tiny stress changes all along the fault, on the North Anatolian Fault, and of course on the East Anatolian Fault, and as you showed, in the Dead Sea Fault. We will have to make measurements locally with high-resolution seismic networks if available. So it's really a very important scientific question for which there is no precise answer yet.
Okay.
Now, independent of the two earthquakes of 2 days ago, the Marmara Sea, through which the North Anatolian Fault runs, has last ruptured in the mid-18th century, around 750. There were two major earthquakes. These were the last ones in the Marmara Sea. And so the North Anatolian Fault in that stretch of the Marmara Sea is ripe to go again. And that means Istanbul, and again Turkey as a nation, needs to prepare for a big earthquake in the Marmara Sea in the next weeks, months, years, decades. We cannot predict when it happens. We cannot prevent it to happen, but we have to prepare for it.
Okay. Martin Mai, I do appreciate you joining us here on our continuing coverage on TRT World, bringing in a scientific approach to explaining or better understanding some of these two deadly earthquakes that has struck the southeastern region of Turkey as well as northern Syria. Thank you.